Hi, and welcome to this blog series around active metro. Today, we will be breaking stuff. So we'll be looking at uneventful failures and actually failing the data center interlink. So let's first look at uneventful failures. So even though we're in the business of breaking stuff today, there are some uneventful failures that I won't be testing because, well, simply because they're not really interesting. So the first one is failing a controller. If I fail a controller on any of the data centers, as you can imagine, the other controller will take over and there will be no event. There will be no failover event taking place. Same goes for losing the witness, right? If I lose the witness server, then no harm done, because as long as the arrays keep ticking, they will continue to serve their I/O. It would be a consecutive error on top of losing the witness, but we'll be simulating that separately when we're doing certain failure scenarios, and we will do it with and without availability of the witness. The more interesting one in breaking stuff is, what if I fail the DC interlink? So failing the link between the two storage arrays. As we saw before, the two storage arrays have no clue what happened. Whether there's a witness involved or there's no witness involved, the response should be the same, because without a witness, the other array doesn't know what happened, so it will stop access to all of the non-preferred volumes. And with a witness, the same thing will happen, because if I fail the interlink with a witness, both of the arrays will talk to the witness and they will understand that they're both still alive, which also means they have to disable access to the non-preferred volumes. So the response will be the same, even though the way it works is slightly different. So let's go on and break stuff, right? Let's fill the DC interlink and see what happens. So moving into the lab, you can see the vCenter interface here. I've got my ESXi servers, I've got my Windows servers, and I actually opened a console to each and every server. So all of the servers, as you can see, they are showing an animated GIF that's running for of Roadrunner, and as we'll be failing stuff, we should probably see one or more machines freeze. So I would actually expect that these two would continue running. These are Windows 1 and Windows 2, which are the two virtual machines that run on the preferred side. The two on the bottom here, they are Windows 4 and Windows 3. So these machines run on DCA, these machines run on DCB. These are the preferred volumes, and these run on the non-preferred volumes. So when I fail the interlink, I would expect that the two machines in the bottom would actually stop responding because they are on a non-preferred volume, while the other two on top, they are on a preferred volume. So let's just move over to the storage array. And the way I'm going to simulate an interlink failure is by basically misconfiguring the network. So I've got the network settings right here. These are actually the storage network settings. So out here I have an unrouted VLAN 1234 that actually takes care of the mirroring between the two arrays. So what I can do is I can select this one and then reconfigure it. And then I need to make sure that there's no workloads running. And of course there are, but I'm going to just continue and misconfigure it. So I'm going to put it in the wrong VLAN. So when I update this, there we go. Network settings were configured. Now let's see what happens. So the machines are still running at the moment, but they'll soon realize that something is going wrong. So if I look at the arrays and I look at the metro, I can now see that they've become fractured. And from both sides, I can actually tell that if I look at metro, yep, it's become fractured, right? There's no longer a connection between the two sites. As you can see, this machine already froze as a result. Of course, it's running an animated GIF, so it doesn't need to do anything specifically. You can see the other machine froze as well. So the freeze won't be instantaneous, but at some point the operating system will need to perform a write, and it can't because it's on non-preferred, so it will stop. And as you can see, the other two machines keep on ticking. So this is shows that it's very important to always run your workloads on the preferred side of things. So, right, so it's vitally important to configure your cluster correctly so that virtual machines always stay on the right side of things. Now, the next thing, of course, is to fix the configuration again. I get some IP network connectivity issues, which makes sense, of course. So let's restore the network and for storage, and I'm gonna reconfigure this once again. And I'm gonna put it in the correct VLAN, and now things should start to repair. So the network settings were configured. If I look at the protection now for Metro, it's still fractured, but it will take a while for the system to discover that the link actually has come back. And after a while, it should start like resynchronizing or rebuilding the workload. Even though the connectivity has been reconnected, the machines are still frozen, right? Nothing happened yet. And at some point, let's look at the other array, what it's doing. It's still fractured. Oh, there we go. Refreshing helped. Switching to Metro, so it's synchronizing back. We should see the same behavior when I refresh here. Yep, it's synchronizing back. And let's just wait for a few seconds for the system to finish syncing, and then Metro will resume. So you can see here that one of the volumes actually is operating normally again. So the sync is complete and it's now running active again. The other one is still synchronizing, but it will finish in just a second. And there we go, right? So now you can see it's all back to active. It's back to their normal behavior. And as you can see, the machines are unfrozen and they're running again, because now they can once again do their writes. I was quick enough for the operating system not to actually crash because of it, the unreachability of its boot drive. So because I fixed it quick enough, right, Windows was able to just resume instead of just crashing out on me. So this basically concludes the first session of breaking stuff, and stay tuned for more breaking stuff in our Metro environment. For now, bye-bye.